This is my constant current digital dummy load. What you see here is a rotary encoder knob, LCD screen that will display the voltage and current, cooling fan, and the air intake is along the bottom here. And on the side is two standard banana connectors. And it is powered by USB. Back, plug it in, turns on. Inside it looks like this. This is the blank circuit board inside, and inside there's also a massive heatsink on the power MOSFET that it uses. It's pretty cool. And for features is, well, give you a voltage and current reading, and you turn the knob to set the constant current setting that you want. So you connect a power supply of some sort to these banana connectors or battery, and you dial up the current, and it'll draw that much current from the power supply. And when this knob glows orange, it means that you are overloading the power supply. It basically means you're trying to draw, say, maybe an entire amp, but the power supply is not giving you that amp. So if it's if it's not within 10% of your setting, it'll warn you with this orange light. So that's what that does. And it'll also give you the voltage reading here is so that, say, your battery, you're drawing an amp from your battery, and it's supposed to be a 9-volt battery, and once you start drawing an amp from the battery, it drops down to maybe 5 volts or something. It'll let you know that it's what the voltage of your power supply is. And if you hold down this button for 2 seconds, it'll glow blue, which means you can turn this, but it's locked and nothing will happen. And you can unlock it by holding it down again. Another neat feature is, well, it's powered all through USB, so basically you can power it with one of these phone chargers or one of these portable battery packs, or, well, you can connect it to a computer. And since it has USB, if you unplug it, hold down the button, and then plug it in, it'll go into a bootloader mode, and you can update the firmware. But the coolest thing is if you just do this while it's running, you can actually go into the serial terminal, and you can do things like set the current digitally through the serial terminal just by typing in commands, or it'll split out the current readings it'll let you log by a comma separated value format what the readings are. And that's useful if you, say, need to do a battery life test. You can leave it on your computer for maybe a few hours, go away, and it'll get you a nice spreadsheet, and then you can use the spreadsheet to get a nice graph out of it to see the battery voltage curve or current, how the battery behaves during the several hours worth of measurement. Right now I have it hooked up to a power supply, and it's supposed to draw about 500 milliamps from it. I could turn the knob, and as you can see, when I change the settings slowly, it'll change by the minimum step amount. But if I turn the knob fast, it'll dial up pretty fast. So that's a neat software feature I have, acceleration for the encoder knob. And like I said before, if your measured current is not within 10% of the setting current, then the orange light will come on. And also on the computer, you can also get the serial port output, which will give you all your measurements, so you could plot a graph or something with that data over a long period of time. Another application for this is if you say you needed to test a power supply that will be running for a long time and you want to see how hot it gets. You know, if you have to put one of these guys in maybe a shoebox inside a car that's going to be in the desert or something, you don't want it to get too hot, you can leave this on for a few hours and take a measurement. Speaking of heat, inside of this thing is a power MOSFET that acts as the floodgate for the current. And if you pull a lot of amps through it, it gets really hot. That's why it has this heatsink on it on the inside. The other designs I've seen of a cheap dummy load, that they're usually open air, and hot air likes to rise, and if there's airflow, they seem to have no problems. But mine is in a box because, well, I wanted all self-contained. I didn't want to have to put a multimeter up to it to take the current measurement. I wanted the current measurement right there. So since it's in a box, the airflow isn't that great, so that's why I put this badass looking cooling fan on it, and it's actually blowing a lot of air, and the air intake's from the bottom, like I said. In closing, this project was mainly inspired by Dave Jones, his video blog, the EEV blog. He put a video of his dummy load up on there, and he explained exactly how it works, and it's a great video. I suggest you go see it. This project of mine, I have documented the entire build process, have pictures of the insides. I have all the design files, firmware files, all up on my website. So if you're interested, please check them out and download the files if you want to see them, if you want to build your own. Take a look. Thank you very much for watching.